A very good morning. Welcome you back to this lesson. Very, very, very amazing lesson. And at this moment, we're going to do some examples that involve solubility. We've not gone far to look at the factors and some effects, but here is a question. Number one, they're saying that the solubility product of lead 2 chloride is 1.6 exponent negative 5 moles cubed per liter negative 3 at 25 degrees Celsius. Solubility has to take place at a certain temperature. Write the expression for the solubility product of lead 2 chloride. For part A, if I'm to give you a hint, this expression is derived from an equation, but I need the expression. But to give you a hint of how it comes about, first write lead 2 chloride is a solid plus aqueous to give you lead 2 ions plus 2 chloride ions. Then the expression KSP is going to be equal to concentration of lead raised to the power 1 times the concentration of chloride ion raised to the power 2. Right, now looking at this, they gave us this, so let's see the main question. Calculate the concentration of chloride ions. Calculate the concentration of the chloride ions. Now the fact that they need the concentration of the chloride ions, I'm going to use a general B Roman 1, I'm going to use a general introduction and say let the solubility, because in the end of it all in Roman 2, they need the solubility. So that the solubility of lead 2 chloride, of course, since we are dealing with one solvent in this particular case, we shall say let the solubility of lead 2 chloride be X, of course, in water, be X. Now, if the solubility of lead 2 chloride is X, it means that the concentration of lead 2 ions would be X moles per liter, since everything was given in moles per liter. But then, because of the reaction ratio, right? Because of the reaction ratio, 1 to 2, it means that the concentration of chloride ion would be equaling to twice the concentration of lead 2. So it will be 2x moles per liter. The moment the student masters this, we specifically use the mole reaction ratio to derive these concentrations. Now, it is from this point that we substitute all that we've gotten into this. So it would imply that the KSP, which is 1.6 exponent negative 5, is going to be equaling to concentration of lead, which is X, times concentration of chloride, which is 2x, then squared. So looking at all this, you're going to have 1.6 times 10 to the power negative 5 equaling to, this is 4x squared times x, that is 4x cubed. So of course you divide by 4, and 1.6 exponent negative 5 over 4 is equals to x cubed. you will take the cube root, both sides, to get the value of x. So x is the cube root of 1.6 exponent -5 out of 4. So this one will give me the value of x as put, you get 0.01587. So this is the value of x. The logic is simple. The solubility of the compound, you can always relate it to be x, and then you look at the equation. Then you substitute into the expression of the KSP. We're going to do more examples. Maybe it will be very, very, very clear. But they need the concentration of the chloride ions. So the concentration of the chloride ions, from here, we say that it is twice x. So concentration of chloride ion will be twice the value of x, which is 0.01587. And this value will come up to be 0.03175 moles per liter. So that is my concentration of the chloride ion. Roman 2 talks about solubility of lead 2 chloride in grams per liter. Remember here you had let the solubility of lead 2 chloride be x, and you got the value of x. It means that solubility of lead 2 chloride, which is the same as concentration, is the value of x, which is 0.01587. So that is the solubility, of course, in moles per liter. So if you have solubility in moles per liter, how do you convert it to grams per liter? First, get the molar mass. You are converting from moles, from moles to mass. So molar mass of PbCl2, lead weighs 207, chlorine weighs 35.5, then times 2. And this one will come up to be 278 grams. So if the molar mass is 287 grams, it means that 1 mole, because molar mass is the mass weighed by 1 mole of a substance. So 1 mole of PbCl2 weighs 278 grams. Then if 1 mole can weigh this, what about 0.01587 moles? So 0.01587 moles they will weigh 278 times 0.01587 grams, and you're going to get your answer in grams per liter as 4.41186 grams per liter. That is what you have. So that is how you'd calculate that question. As simple as this. Let's do some other example, and then we see. Let's do some other example, and then we see. Example number 2 says, part A, write equation for the solubility of silver chromate in water. Then part B, give an expression for solubility product of silver chromate. Then part C, calculate the solubility of silver chromate in moles per liter at 18 degrees Celsius if the solubility product is 2.5 exponent negative 12 mole cubed liter per negative 3. That is what you're having. That is what we are having as our question here. And we can start on it and you see how easy it is. Write the equation for solubility of silver chromate. So for part A, we shall have our silver chromate solid plus aqueous to give silver ions and chromate ions. Part B, the expression for KSP, as we said, it's the product of the molar concentration of the ions from a sparingly soluble salt of a saturated solution. So power 2 raised to appropriate powers, then times the chromate concentration. And that is it. Part C, calculate the solubility of silver chromate. I'm going to let the solubility of silver chromate BX. So if I let the solubility of silver chromate BX, then now I will talk about the independent ions from saturated solution of silver chromate. So it means that the concentration of silver ion is a plus, will be equaling to, by looking at the ratio, it will be twice X. Whereas the concentration of chromate will be X, moles per liter, moles per liter. Now, from the expression of KSP, which is silver ion concentration squared times the chromate ion concentration. The value of KSP was given as 2.5. So it is silver ion concentration, which is 2x, but squared 10 times the value of chromate, which is x. This one automatically would bring 2.5 exponent negative 12 is equals to, this is 4x squared times x, that is 4x cubed. Implying that the x cubed is equals to 2.5 exponent negative 12 over 4, giving the value of x as the cube root of 2.5 exponent negative 12 out of 4. And this will give you the value of x as 8.5499 times 10 to the power negative 5. And because you had let the solubility of silver chromate to be x and we've gotten the value of x, we conclude and say solubility of silver chromate is, you write the value 8.5499 exponent negative 5 moles per liter. That is how you get it. So it's all about getting the values. Rather, it's all about using the equation very well to get the ratios. Yeah, to get the ratios of concentration. To do another example. Example 3. It goes calculate the solubility product of strontium fluoride if its saturated solution contains 1.6 exponent negative 3 grams per decimeter cubed at room temperature. Strontium is that, while fluorine is that. Calculate the solubility product. Now they need KSP. In all other cases, they have always given us that case, but in this case, it's what we are looking for. In this case, it's what we are looking for. Now, the first thing still is to write the equation. Strontium fluoride, solid plus aqueous, establishing equilibrium from strontium ion, fluoride ion. Then still we write the KSP expression, concentration of strontium times concentration of fluoride raised to the power 2. Now, they gave us the solubility in real case, in real sense. Calculate the solubility product. They need a solubility product. But they are saying if its saturated solution contains this, it means that this is the solubility of strontium fluoride, though in grams per deciliter cubed. So the moment we have this, you can say let the solubility of strontium fluoride be X. Let me call it X moles per decimeter cubed, because since they are in grams, I need to convert them to moles. Now, if the solubility of strontium fluoride is X, it means that the concentration of strontium ion is X from the mole ratio, and the concentration of a fluoride ion will be, because of this two, should be twice X moles per decimeter cubed. It will imply that I need to first get these concentrations, then I substitute here, I get the value of KSP. But to convert this concentration from grams per decimeter cubed to moles per decimeter cubed, I need relative formula mass or molar mass or relative molecular mass or molecular mass itself of strontium fluoride, and that is going to be equal to 87.6 plus 19 times 2, because there you have 2 atoms of fluorine. 38 plus 87.6, 125.6. Because of the relative, no need of putting a gram. Now, if I'm converting mass to grams, I'll be saying that that molar mass, 125.6 grams of strontium fluoride contain 1 mole. Contain one mole. If 125.6 contain 1 mole, what about this mass? So 1.6 exponent negative 3 grams of strontium fluoride contain 1 times 1.6 exponent negative 3 of 125.6 moles. So this one will give us our concentration of strontium fluoride as 1.2739 exponent negative 5 moles per decimeter cubed, because I'm converting grams per decimeter cubed, and I've gotten my answer as this moles per decimeter cubed of strontium fluoride. Now, it would mean that the concentration or the solubility of strontium fluoride is equal to 1.2739 exponent negative 5 moles per decimeter cubed. Mean that the concentration of strontium fluoride will be the value of X, which is the solubility of strontium fluoride, which is 1.2739 exponent negative 5 moles per decimeter cubed, while the concentration of fluoride ion will be equal to 2 times the value of X, which is the concentration of strontium fluoride, which is 1.2739 times 10 to the power negative 5. And this will give me, 2.54 exponent negative 5 moles per decimeter cubed. Therefore, the value of KSP will be equaling to concentration of strontium. So I substitute concentration of strontium ion. This was supposed to be strontium ion, please. Strontium ion. Concentration of strontium ion, 1.2739 exponent negative 5 times the concentration of fluoride ion squared, so 54777 exponent negative 5n squared. And this is going to give me 8.269 times 10 to the power negative 15 mole cubed decimeter power negative 9. In our previous video, we looked at how we get the units for these values, okay, for the KSP values. So that is what we are supposed to get. That is what we are supposed to get. Right. So this is it that we are supposed to get. 8.269 exponent negative 15. I guess each viewer can do this question. It's related to this. At 25 degrees Celsius, saturated solution of V2 chloride in water contains 1.1 grams per liter saturated solubility product at this temperature. That is for all the viewers. Then I do a fine example for this particular area. And the example I'm going to do is still related to what I've been doing. If the solubility product of magnesium hydroxide at 18 degrees Celsius is 4.2 exponent negative 12 mole cubed decimeter power negative 9 calculate the solubility in moles per liter at 18 degrees Celsius of magnesium hydroxide if it is sparingly soluble in water. As we've seen, the main thing is first write the equation, then the expression, magnesium hydroxide solid dissolves in water Mg aqueous plus 2OH aqueous. So the Ksp is the concentration of magnesium and the concentration of hydroxide squared. So if we let the solubility of magnesium hydroxide in water, since we are just dealing with water, if we let it to be X, then it would mean for it to be X moles per decimeter cubed, then it would mean that the concentration of Mg is X moles per decimeter cubed, and the concentration of hydroxide will be, from the reaction ratio, it will be twice X. So in substituting, we have it that Ksp is that. So we substitute the value. So it should be 4.2 exponent negative 12 is equal to concentration of magnesium, which is X times concentration of hydroxide, to X squared. So 4.2 is equals to 4X cubed. A very keen eye should be given to this. Students sometimes forget. They forget squaring the figure. You square everything. The power affects everything in the bracket. So if it is 2X, the 2 will become 4 and X will become squared. Then you multiply another X to become cubed. So here you can really see that X cubed is 4.2 exponent negative 12 over 4, giving you the X as the cube root of 4.2 exponent negative 12 over 4. And this one will give us the value of X as 1.02 exponent negative 4. And then we conclude that the solubility, because you had let it to be X and you've gotten X, so you will say that the solubility of magnesium hydroxide in water is 1.02 times 10 to the power negative 4 moles per decimeter cubed. That is how we get the solubilities. And now after this section, we shall be heading for the most wonderful section of the common ion effect. So our next lesson will look at common ion effect, or effect of adding a common ion to a saturated solution of a sparingly soluble solid. We shall enjoy that. For now, have a blessed time.